Okay, I'm going to give you another reaction to balance now. We're going to do calcium carbonate reacts with phosphoric acid to form calcium phosphate and carbon dioxide and water. So if you can balance this reaction, you can do anything, because this is really tricky. And the reason why it's tricky is if you check it out, calcium carbonate has oxygen in it, phosphoric acid has oxygen in it, calcium phosphate has oxygen in it, carbon dioxide and water both have oxygen in them as well. And this is chemistry students' nightmare, having all those oxygen atoms, because they can be really difficult to deal with if you don't know what you're working with or how to do it. All right, so we're going to list them: calcium, carbon, oxygen, hydrogen, phosphorus. We don't have to write oxygen again. And on the other side, in the same exact order, even though they don't appear that way, we're going to write them as well. All right, now we got to take inventory. Calcium, before we do anything, has 1 atom. Carbon is 1. Oxygen, 3, and 4 is 7. Hydrogen, 3. Phosphorus, 1. Remember, polyatomic ions, the subscript only belongs to the atom that it's next to. That's it. All right, calcium here on the product side, 3. Carbon, 1. Oxygen, got to be careful. 4 times 2 is 8, plus 2 is 10, and 1 is 11. Hydrogen, 2. Phosphorus, also 2. The phosphate is in parentheses, indicating there's 2 of those, so there's 2 phosphorus atoms in all for that. Okay, now I got to pick our battles. What should we start with? Well, we always start off with the most obvious thing that we can do. And since calcium is 3 here, it would be ideal to have calcium 3 on the other side, on the reactant side. So we'll put a 3 there. I think the red's better than the green. The green was kind of wimpy. Couldn't really see it too good. All right, so calcium, 3. Carbon, 3. Oxygen, got to be careful. 3 times 3 is 9, and 4. 9 and 4 is 13. Okay, moving along. Carbon. Well, carbon's 1. This is 3. Let's make this 3 as well. If we make a 3 in front of a carbon dioxide molecule, that's going to change how many carbons we have. 3. Oxygen, got to be careful. 4 times 2 is 8. 3 times 2 is 6. 6 and 8 is 14, plus 1 is 15. Okay, now we have hydrogen 3, hydrogen 2. That's trouble right there, because if you multiply this by something, you're going to screw that up. So let's wait. Phosphorus would be a smarter move. If this is 1 and that's 2, let's make it 2 here. So if we put a 2 in front of the phosphoric acid, that will now give us 6 hydrogen atoms. Phosphorus is 2. And oxygen now, we got to recount. 3 times 3 is 9. 2 times 4 is 8. 9 and 8 is 17. Okay, hydrogen 6, hydrogen 2. If we put a 3 in front of the water molecule, that will solve that problem. It will give us 6 hydrogen atoms. And now what we have to do is recount the oxygens. 4 times 2 is 8. 3 times 2 is 6. 8 and 6 is 14. And another 3. Ta-da! 17. See what I said to you about oxygen? It works itself out. Done.